For you who didn't hear me before, I'm Maria Ljung. I'm the communications manager for the project. I'm representing RISE Research Institutes of Sweden. We will start this briefing with a short presentation from the project manager, VALUE3S and Julie, who also represent the RISE Research Institutes of Sweden. The presentation will be about 10 to 15 minutes, and during that period, you will be muted. After the presentation, we open up for questions. We estimate that the briefing will last for about 30 minutes in all. I also want to go through some simple rules. As I mentioned, we will keep you muted during the introductory presentation, but you can ask questions right away in the chat. These questions will be answered after the presentation. During the question and answer session, you can raise your hand to speak. This feature you access by opening the participants view in the bottom panel in Zoom and choose the raise hand symbol, which is to the left. I know that in some mobile apps, this feature is found under More. During the presentation, we ask you not to use the chat for questions like practicalities, reactions, etc., but to mainly limit yourself to questions concerning the project. That is if you don't encounter some urgent issue. I also hope that you have all been informed that the meeting is recorded and that the recording will be used as part of the project documentation. We hope you accept to be part of this recording. If not, we recommend that you change your screen name, turn off your video camera, and stay muted throughout the meeting. After the meeting, you will all receive an email with documentation from today's briefing and some more stuff. Are there any questions right now? You can raise your hand if that's the case. And if you have problems find the raise the hand function, you can write it in the chat. If there are no questions right now, I'm handing over to Bruce and Julie. Welcome, Bruce.
Thank you, Maria, for the introduction. Hi, everyone. It's an honor to present the project to you today. VALUE3S is a 3-year ECSEL project that started in May. Today, I will provide you with a little bit of details about the project, starting with some backgrounds, especially on automated systems. So automated systems have been around for so long. Automation is when a technology is used to minimize the human assistance in a process or procedure. Today, I decided to provide you with an example about time and show you how long ago automated systems have existed when it comes to the concept of time. Here you see a picture of a water clock that uses the flow of water in and out of a container to measure the passage of time. The technology was used in Babylon, Egypt, and Persia as early as 400 years before Christ. Although it facilitated and it helped the users of this technology to measure the passage of time to some extent, I assume that you agree with me that more automation could have been applied to this technology, which was something that happened. Water clock was further developed and new fancier functionalities were added to the water clock. For example, figurines. You've seen water clocks with, that have, for example, figurines that opens doors. They had bells, and the biggest achievement in technology was done by Eusebius on the 2nd century before Christ, where he integrated and incorporated gears and dial indicators in these clocks. For more than 1,800 years, the water clock was the most accurate clock ever constructed, until the invention of the pendulum clocks in 1656. From its invention until the 1930s, the pendulum clocks were the world's most precise timekeeper. In the 1930s, we had the introduction of synchronous electric clocks, and nowadays we have digital clocks. We have atomic clocks that have a very high precision of measuring the passage of time in an automated way. Although this was just an example to show you the fact that automated systems and automations have been around for a long time, nowadays automation is heavily used in safety critical systems. These systems are the ones where failures in them could harm a human being and could damage the environment. There are plenty of examples of different domains that one can give on the usage of automated systems in safety critical systems. For example, in the automotive domain, there are lots of functionalities. You are all aware of cruise control, for example, and many other simpler functionalities that have been automated. In the industrial robotics, there is a lot of usage in the human-robot interaction. There are certain robots that are encaged, of course, not to have a negative influence on human life, but there are also robots that are being incorporated in the interaction between human and in the assembly line. Agriculture robots are also have also very high usage on the automated systems and this domain, especially when it comes to positioning, orientation, navigation, planning, and sensing. The usage of automated systems in the avionics and the aerospace have also been very common. You might be aware of, for example, the fly-by-wire system and a lot of other functionalities that are implemented in the engine controllers. In the health domain, automated systems are also being used, for example, for monitoring specific vital sign parameters. In pacemakers, for example, they are used. And if something goes wrong with these systems, I hope that you all agree that human life could be endangered. And the last example that I had here today was on the railway domain, that also a lot of different functionalities have been automated. These are all examples of the domains and cases where automated systems needs to be safe, and we need to make sure that these systems follow the specifications that we have defined for them. Manufacturers of these systems have been allocating an enormous amount of time and effort in the past developing these systems and conducting research on these systems. The effort spent has resulted in availability of prototypes, demonstrating new capabilities, as well as the introduction of such systems in the market within different domains. Functionality has always been in the center of attention. This is especially due to the fact that we would want to get these systems into the market, or they would want to get these systems into the market as soon as possible. However, between development prototypes demonstrating some features and capabilities and the production version, there are several steps to take, especially to make sure that these systems are safe and secure. Manufacturers of these systems need to make sure that the system functions according to specifications, which is not a trivial task to do, especially since the complexity of these systems rises dramatically the more integrated and interconnected these systems become. With rising complexity, unknown emerging properties of the systems may come to the surface, making it necessary to conduct thorough verification and validation of these systems. In early development stages, the focus is more on verification activities like review and testing to check that the system is being developed correctly. During the final stages, validation activities are often mandatory to check that the system provides its intended service. The verification and validation needs to take into account requirements such as safety, security, as I mentioned. Here, security deals with threats to the system or equipment from the outside world, causing failures through, for example, intended attacks. Functional safety is about protecting people, processes, and systems and environments from hazards. The high complexity of automated systems incurs also an overhead on the verification and validation of these systems with respect to safety and security. And it makes it very much time-consuming and costly, which is exactly where the values projects come to the picture. Here, I present you the high-level objective of the project, which is to design, implement, and evaluate state-of-the-art methods and tools that reduces the time and cost needed to verify and validate automated systems with respect to safety and security requirements. In the remaining of this presentation, I'll be going through the activities that we plan to do during the project in this 3 year in the project, by addressing the different parameters of these objectives and connecting it to the project activities. In the project, we plan to develop a multi-layered framework enabling more effective verification and validation. To do so, we create at least a 6-dimensional verification and validation framework that has multiple layers. Basically, these dimensions and layers are the components that we need to have in order to conduct the verification and validation process in order to obtain our goal for improving time and cost. We also suggest and validate new as well as state-of-the-art evaluation scenarios for safety and security evaluation. This is through introduction of several test cases and scenarios that allows us to express a use case and focus on certain scenarios that we find important. We also plan to overcome the safety and security gaps and limitations of cyber-physical systems. This is done through improvements of at least 14 verification and validation methods, and presents a novel standard compliant verification and validation workflow that is generic to reference method for cyber-physical in cyber-physical domains. So here, the main focus is on getting the competences of the partners within the project who have competences on different verification and validation methods, and marry them in order to gain from the competences of partners within one domain to improve the verification and validation process. We do not stop here just by looking at the method. We also plan on developing and improving verification and validation tools that exist. The plan is to improve and develop at least 24 tools within the project that allows us to incorporate the implementation of the methods that we had conducted in the project. We also incorporate and make use of safety and security evaluation criteria. Here, in the objective, the main focus is on time and cost. However, there are several different parameters that one needs to take into account to express the improvements obtained. Now that we have methods and we have a framework and we have tools developed, we also plan on demonstrating, verifying, and validating the usefulness and wider acceptance of the proposed framework by realistic pilots. This is done through the evaluation of the framework, methods, and tools on the use cases of the project. We have 13 use cases in the project from 6 different domains of automotive, railway, aerospace, agriculture, health, and industrial robotics. That is going to allow us to evaluate these use cases within these domains, and also to learn from the lessons that we obtain and gain from each of these domains, to see if there are applications in the other domains that can learn from those lessons. We also, in the project, we will also influence, and we have created a plan to influence the development of safety, security, and privacy standards through active participation in related standardization groups. Several of the partners within the project are involved in different initiatives and standardization groups. Values will provide guidelines to the testing community, including engineers and researchers, on how the verification and validation of automated systems could be improved, considering the cost and time and effort needed to conduct these kind of evaluations. And last but not least, there is a big focus in the project on dissemination and disseminating the project results, aiming to increase the awareness on the importance of conducting safety and security evaluation. This is done through publication of newsletters, scientific articles, open access conferences and journals, and by communicating through our platforms, websites, and social media, and as well as by focusing on addressing some of the United Nations Sustainable Development Goals. For example, on the third goal, which is good health and well-being, reduce the number of deaths and injuries in road traffic. We look into this goal by the achievements that we obtain when it comes to the verification and validation of intelligent autonomous vehicles with respect to the use cases that we have defined in the project. On goal 9, which is innovation and infrastructure, increase research efforts and technical capacity in the industrial sector. The Values project has 26 industrial partners that contribute to the project. On goal 11, which is on sustainable cities and communities, make sustainable transport system available to everyone. Values focus partly on cyber and personal safe vehicles. And on goal 17, which is partnership for the goals, we collaborate and share knowledge about science, technology, and innovation in and outside the project. You might agree with me that these are very challenging objectives and goals that we have set in the project, and that is the reason that we have created a strong consortium consisting of 41 partners from 10 countries that brings their competences in the project and contribute to the different activities and goals that we have set in the project to reach. The consortium consists of 6 research institutes, 10 large-scale enterprises, 15 small and medium-sized enterprises, and 10 universities. The total Horizon 2020 project cost is more than 25 million euro. And the project has received funding, as I mentioned, by the ECSEL Joint Undertaking. The Joint Undertaking receives support from the European Union's Horizon 2020 Research and Innovation Program, and in the case of VALUE, Austria, Czech Republic, Germany, Ireland, Italy, Portugal, Spain, Sweden, and Turkey. With that, I end my presentation, and I would be very happy to answer any questions that you might have. With the side note that there are more details about the project, for example, the structure of the work packages, and a little bit of more information about the use cases on our website that you can see on the screen right now. So feel free also, if you haven't visited our website, to do so and to get a bit of more information. Please let me know if you have any questions, and I would gladly answer your questions. Thank you.
Yes, so now you're free to raise your hands or write a question in the chat. And if you want, start your video camera so that we can have a bit of a question and answer session. No questions at all? Well, I wondered, you mentioned the challenges that are quite large for this project because there are so many domains and many partners and countries. Which challenge do you think is the most challenging?
Mm-hmm. So as I mentioned, verification and validation have been addressed in several standards in the past, and several of the partners who are in this consortium has been also part of other projects that had this focus. I think the challenge for us is to address it from another angle, which is the improvement of these processes, because they are time-consuming, they are very costly. And we have one way of thinking about this, that by merging and by marrying these methods that have been proven in certain domains with the methods that are being used in other domains, we're going to be able to improve these processes even further. So one challenge that I see there is the definition of proper metrics to measure these improvements that is obtained. Of course, time and cost is one of like two of those metrics, but there are several other things that one needs to take into account to measure what we mean by improvement of time. Is it the number of hours that we spend on testing? Is it some other metrics that is of importance that one needs to take into account? And this is, I think, of the most importance when it comes to measuring security, because safety has been also around for a long time. But security metrics is, I think, one of the challenges, that we define proper security metrics in the project, something that lots of researchers have attempted to do in the past. Not only to define those proper metrics, but also to define improvement metrics to express system security.
You have a question right now, and Ahmed, you can feel free to unmute and put a question in speaking if you want to. Otherwise, I can read it.
Okay, I have written the question. Actually, autonomous systems are new to the whole world, we know. So, do we expect a revolution for testing with this project? What is the role of our state of this project for testing new autonomous systems?
So autonomous systems in certain domains, if we think about some of these domains that we might have heard of more, like the autonomous vehicles, there has been much more activities in the past years on these systems. And as I mentioned, I believe that a lot of the focus is on the functionality. Of course, there are works and groups within these organizations that are developing this system that focus on safety as well. However, what I see as a challenge here, and it's something that we partly also address in the project, is to look at safety and security not from separate entities, but to look at them as an entity that they can influence each other. I have chatted with some major organizations that work with development of autonomous vehicles, for example, that in some cases these departments are separate departments, so there is not much interaction going on, whereas the engineers, the safety engineers, from our point of view, needs to be very much connected to the security engineers, because if there is a system that has security flaws, one can influence the system safety as well. So the challenge that I see there is, apart from, of course, the implementation of these systems and the advancement that have been obtained in the past, is to look into these other requirements like safety and security, and also look into the interplay between safety and security and how they can influence one another. Did I manage to answer your question, Ahmed?
Yeah, thank you.
Welcome.
Anton, you have a question?
Yes, I have a question. Just to keep it going in the same direction as it was until now, in the autonomous systems, there is a lot of AI lately, and there are quite some serious questions about safety and security related to the algorithms used inside. So how the project addresses this?
Mm-hmm. Thank you, Anton, for the question. Yeah, that's a very good point. So the project also has a huge focus, especially on partners who have expertise on the AI, that addresses the verification and validation process for the AI. It's a very challenging and yet interesting domain, because there is a lot of concepts on dependability, safety, and security that has been applied in the ICT systems and in the way that we have looked into the system so far. And what happens right now is that many of these concepts are being applied to the systems that are AI-based or machine learning-based systems. In many cases, this might be a good start. However, the wheel might need to be redefined here, because many of these algorithms and verification validation systems cannot be directly mapped to the system that are AI. Because the way that, for example, we verify the system, or the way that we conducted, let's pick fault injection experiments on a system that we knew where we enter the system and where we exit the system and what expectations we have from the system, is much easier and different than the way that we look at an AI system, where there is a lot of decisions that are being made that makes it complicated for us to define whether we makes it complicated for us to understand whether we completely understand the system before we conduct an experiment on this. And one problem here is the testing these systems, but the other problem is to implement safety mechanisms for these systems and to evaluate these safety mechanisms, because these safety mechanisms and security mechanisms might also be completely different. So the way that the project is going to focus on this is that with respect to the framework, we will integrate AI systems in the framework, and we will identify different elements that needs to be added into the framework with respect to the AI system. When it comes to the method part, we look into the methods that have been used in the past in other domains to see if we can integrate them into the AI system, or if we can come up with new suggestions on a method that needs to be used for AI evaluation. When it comes to the tools, it goes with the same line with the methods that I mentioned before. And this is also something that we are going to look into some of the use cases, because we have perception algorithms that uses machine learning algorithms. We have in some of the use cases object detection and object classification that uses machine learning and AI algorithm. So these are concrete examples that we can use as systems and start evaluating them, start bombarding them with faults, start evaluating them theoretically to see whether they are safe and not or not. So it's a whole value chain from the framework to the method, tools, and then the evaluation at the end, which we will focus on in the project as well.
Reza.
Do you hear me?
Yes.
Okay, thank you. This is Reza. I am representing QRTech. I just was assigned as a new project manager for this, for our part of participation. I have two questions. One is that because I'm new, probably you have described this a lot of times before, but I will ask you anyway. What is the main difference in our approach in this project compared with the previous works and the previous standards, so we can have this as one of our main achievements after the project is finished? What's the difference in the way that we will work and the results that we will present? And the second question is that exactly how we'll try to present the result out of the project so it will be used by the industry in the best way. Thank you.
Thank you, Reza, for the question. So I think I might be able to answer both of those questions in my, to me, both of those answers are connected. So one of the things that we do in the project, as I mentioned, is this framework that we develop. This framework is a methodological framework. So it's going to be a lot of connections between, okay, if we want to evaluate a system, what kind of methods do we need, and what kind of methods exists right now, and what kind of tools exist right now, and how do these tools and methods allow us to verify and validate the system. And throughout the project, we look into what is missing. And right now, there is no single repository that gathers all these kind of information to allow us to know what is missing. What we do in the project is that since we have multiple domains, we are going to be able to see what exists in these domains, and in order to allow us to identify what is missing. And that part that we identify is going to be the focus of the development when it comes to the development of improved method and improved tools. When it comes to the usage of the project result in that is, even though the framework is a methodological framework, all its element is going to be stored in a web-based repository. During the course of the project, we are going to develop this web-based repository. We design it, we fill it with data after the analysis that we do in the domain, what methods are available, what tools are available, what evaluation criteria are available, and we populate this database with the information that we gathered. as well as populating it with the new improved methods and tools that we identified and developed in the system. So all these lists with respect to the development, and if there are even which partner have been working on the development of this, and also if we have preliminary results about that specific improvement process, we put it in this database. This database, after the end of the project, is going to be available. Of course, it's as I said, it's a methodological database, so it's going to have like the tools themselves and some other concepts there, but it has references depending on the partner that developed the tool and the licensing of the tool. It would have references that certain partners have developed this tool, and if you use this tool, you're going to be able to focus on this part of the verification and validation, and you're going to be able to, if you use, for example, a certain simulator, if you use a certain type of hardware, you're going to be able to gain this much of verification and validation time. So this information is going to be available after the end of the project as pointers that point practitioners in the future that would like to the art and what are the development done under the project, to direct them to the right path. And of course, if there are open source tools that are developing the project, there is pointers to those places where those material can be retrieved and can be used. There will be, of course, connections to, if there are scientific publications that connects directly to the method, the tools that is developed. All this information is going to be gathered in this database that is going to be publicly available after the end of the project. And to answer partly about what has been done before and now, we have also created a strong set of connections. So the project partners have been working in several other projects, and the plan is also to integrate the lessons that they've learned from that project. This is also to create a continuous connection with the projects that are still ongoing right now. So this is going to be further explored during the project, because we have already identified the relevant projects. We have already identified the partners who are going to be in contact with these other projects. And as far as and as I mentioned, the plan would be to look into what has been done, what is missing, and how much more can we do to improve the verification and the validation process. And this framework that we develop throughout the project and populate at the end is going to be a result that is going to be living further on. I hope I managed to answer your question, Reza.
Yes, sure. Thank you very much for the explanation, and thank you for an interesting presentation. Thanks.
You're welcome.
There's another question. Alesh, is that rightly pronounced?
Yes, hello.
Yes. Hello.
That is partially answered, but what is our vision of the future about the results achieved in the project? How the ideas will continue after the end of the project? What do you like it would be?
So I think partly I answered it in Reza's question, but I will repeat part of that, and that was the focus that we have on making this repository and the framework to stay alive after the end of the project. So when the project ends, throughout the project, this repository is going to be, as I said, the framework is going to be designed, further designed, because we have partially designed that in the proposal and updated, and then this is going to be extrapolated into a database that is going to be available throughout the project for the project partners to fill in and to identify the parts that could be improved. And then after the end of the project, this repository is going to be available as planned. So this is one, I think, major part of the contribution that we are going to provide to the community. But in addition to that, the focus that we have on improving the methods and tools, and also the fact that we have 6 domains in the project, and that there are certain concepts in one domain that one can use in another domain. We have already started identifying, going into the use cases, and there are certainly use cases that are from complete different domains but could benefit from development of a certain functionality. So these are obvious usages of this framework where these domains may not have communicated with each other much before. They have their own certain standards, their own guidelines, and that they normally follow. But with this project, they're going to start communicating, and they understand that there are certain features and processes that others in other domains that are a bit more advanced maybe have been using for a while, and they incorporate it into their development. But to go back to the question that you asked, I think the major thing, apart from, of course, the development of the tools and the verification and validation process improvements that we envisioned, we would like this repository to be something that is going to be used after the end of the project. Yeah. And that is the plan for now. It's certainly going to be updated. We have already started discussing this in the project with a technical committee group to start looking into other ways of making sure that the project results could live after the end of the project. Hopefully in future press releases, we would have more information about our visions in addition to what I mentioned now. Did I answer your question, Alish?
Yes, thank you. Actually, I was hoping that you answer it in more not focusing on the project, but your personal vision or your personal wish, even though if they would not be realistic.
Yeah. So if I go back to the personal wish, that was also maybe the trigger for the project. So we implement a lot of functions in the lab. There are a lot of partners who have focused, or a lot of companies in general, or researchers who have focused on looking at a piece of code, a piece of software. They test them in the lab. And then after this, many of these state-of-the-art research might not be propagated all the way to when it comes to the usage of these technologies. So what we started chatting about from the beginning of the project was to have a focus on the environment, where we not only look into the pieces of software and codes in the lab, but also go one stage up and to evaluate these systems that have been developed in the lab in a closed loop, basically, environment where everything is protected and you can test these systems. And then take this one step up higher to the actual system where you test this in the mission, or when you test it in real world, let's say traffic or things like that. So what I would like to see here is we have different focuses, and this is great to focus on different layers, is to go actually all the way through, and not only to implement something on hardware, take that, or in the lab, take that and put it into a system, and then take that and put it into a real action to have something concrete. And I think we are going to be able to obtain this by the end of the project, or this is something that is going to continue development after the end of the project, because the use case providers, they have use cases that are very strong, and their use cases are complete. So we have actually the possibility to understand what components they have, start evaluating them and applying them in their use cases. So hopefully by the end of the project, or it might be a bit longer than the end of the project, this focus of going through all the layers is going to be a wish that I would certainly have. But I have a lot of other wishes. The interplay between safety security, I think it's very important. Anton talked about the AI, and I think if we manage to define very useful metrics on the security to measure system security, I think it's going to be very valuable. But in addition to that, to be concrete, how do we measure the improvements that we have obtained in this system with respect to safety and security, and to always be an advocator for the fact that these non-functional requirements, they need to always be taken into account in a joint way. And this is one way that we can improve these verification and validation processes, by not having parallel groups working on something, but by actually looking at it as a team. So I shared with you some of my wishes and hopes. I hope that answered your question, Alice.
Yeah, thank you, thank you.
Well, maybe those wishes are a good point to finish this press briefing, if there isn't any more questions right now. I would like to thank you all